Time for the third and final video with establishing the identities for trig functions. So we've already gone through two, and we went through a couple different examples. The ones in the very beginning were not as complex, kind of straightforward. Now we're getting into the more complex types where they look a little ugly to get started, but afterwards, after doing the work, it won't be so bad in theory. So let's see how it actually pans out. So remember that when we were talking before, we said, hey, if I've got a sine and a cosine and maybe a tangent, I want to turn everybody into sine and cosine. Here, though, I've got cotangent and tangent. If you also look at the very end, I only want my answers in cotangent and tangent. So my choice here is to keep everybody in cotangent or tangent. So I'm going to turn everyone into a tangent and work from there. So let's go ahead and work this out. We're going to start with the left-hand side. It's going to be tough to fit everything in this one because of just how long it's going to take, but we'll do our best to try to fit everybody in here. So cotangent theta divided by 1 minus tangent theta. And I think as I'm writing this, this is a good opportunity to remind you that you need to rewrite this and just rewrite the side that you're going to do all the work for. So you rewrite that side first and then start doing that work. So now, excuse me. Whew. All right. So now we're going to go through and convert everybody. I'm going to go through and convert everyone to tangent. Why not? All right, so go through and convert everybody to tangent. So that means in the beginning I've got 1 divided by tangent, all divided by 1 minus tangent, plus tangent theta divided by 1 minus 1 divided by tangent theta. Okay, well, let's go through and do the work. If we, looking at how this is going to be, I want to try to get the denominators the same so I can bring them together. But maybe I'm going to go through and do some work here to make my life a little easier because I don't want a fraction within a fraction. So, I'm going to do two things at the same time. I'm looking at this one fraction, and I'm going to rewrite this as, the 1 divided by tangent of theta. And I remember division is the same as multiplying by the reciprocal, so I would be multiplying that by 1 divided by 1 minus tangent theta. And over here I'm going to get common denominators, so I'm going to have plus, again my numerator is just plain old tangent theta. And my denominator is going to have a complex fraction down here. I've got tangent theta divided by tangent theta minus 1 divided by tangent theta. So let's clean this up, make this a little bit easier to deal with. I've got 1 divided by tangent theta times 1 minus tangent theta, plus my numerator just stays as tangent theta divided by, and then I got to bring this stuff together, so I get tangent theta minus 1 all divided by tangent theta. Remember I said I was going to be running out of room here pretty soon. Well, we've pretty much gotten there. So now I'm going to rewrite this expression, 1 divided by tangent theta times 1 minus tangent theta, plus, and now we got to clean this up. So this would be the same as multiplying by the reciprocal. So I'm in my numerator now. When we flip this, I'm going to have tangent squared in the numerator. And in my denominator, I'm going to have tangent theta minus 1. All right. I don't have a lot of room here, so I'm going to actually add a slide. So give me 1 second here because I just don't have enough room. So we're going to go through and add this slide just so I have enough space. Go ahead and set my background, and I'm going to rewrite what we have there. So we've got 1 divided by tangent theta, 1 minus tangent theta. So all I'm doing is just rewriting what my last step was from the other one. Plus, so let me go back one slide and see what else we had here. Tangent squared theta and then tangent theta minus 1. So oops, there's no 2 there. Let me delete that. Sorry about that. All right, so we got too many things going on here in the denominator, so I've got to do some introduction of new parts. This first off, if I change this order, that will make my life a little easier. So I'm going to go through and change that order. So I've got 1 divided by tangent theta, and then 1 minus tangent theta. If I take a negative sign out of here, then I'll end up with the same thing we've got here. So I want a negative so that I can have in parentheses 1 minus tangent theta. And I already have a tangent squared up here, but to get common denominators, I got to introduce another tangent theta. So by doing that, I now create a tangent cubed theta. So now my common denominators turn into, all right, so I've got one common denominator of, we'll say tangent theta times 1 minus tangent theta. And my numerator is 1 minus tangent cubed theta. All right, so here's where we have a little bit of an issue because we have to remember how to factor a cubic. All right, so I've got my tangent in the denominator and a 1 minus tangent theta. Factoring a cubic. All right, if you don't remember how to factor a cubic, you might want to take a second, look up what you need to do that. So I'm going to go through and do it out. I'm going to get a 1 minus tangent theta. And then it's 1 plus tangent theta plus tangent squared theta. All right, and again, running out of room. I am not creating a new space for it. I'm just going to move it up here. And the 1 minus tangent theta will go away, so that makes life nice. But what I need to do now is I have 1 plus tangent theta plus tangent squared theta, all of which is divided by tangent theta. All right, if you're starting to forget what we need this to become, let's go back. I need this to be a 1 plus tangent theta plus cotangent theta. That's what we need to eventually get. So we're almost there. We're getting just like these 2 parts. So I'm going to divide every single thing by tangent. So if I divide every single thing by tangent, I get 1 divided by tangent theta plus 1 plus tangent theta. All right, so let's go back. What am I supposed to be looking at? Okay, so I need a cotangent, a 1, and a tangent, and they're all added together. So I look here, and I can see that this is going to be cotangent. And then this will actually give me everything I need. I just have to change the order around. I have a 1 plus, I forget the order already, just from one screen. There we go. 1 plus, I'll take the tangent theta, move it here. And then I'll move this one plus cotangent theta. This is one of the longer ones, and now notice we've got to be able to factor still. All the stuff that we've ever done, we still have to be able to do. So that's talking about adding, subtracting fractions, getting common denominators, multiplying, dividing fractions, factoring, so I can get down to smaller factors, and whether that be a greatest common factor of factoring, whether it be factoring a quadratic or factoring a cubic even, we have to be able to do these parts. All right. And that's what's going to make it difficult. I mean, we've talked about all year long. Look, the stuff for pre-calculus, we're taking everything that you've ever done and we're throwing it all together at you. All right, so let's take a look at this example here. I'm going to start with the left-hand side again because I've got stuff here that I can manipulate and then see what we get to get it close to here. So I'm going to start with that left-hand side again. So secant theta minus cosine theta, because no matter, even though this is what I'm going to adjust and what I'm going to manipulate, I still have to rewrite it first. Now we go ahead and start manipulating this left-hand side. Again, knowing that this is where I want to be, I can only adjust one side at a time. I cannot start adjusting both sides. Because by adjusting both sides, then you're no longer establishing an identity. You're just trying to, move everybody to one side. You're not really establishing an identity. The idea of establishing an identity is to show that one side, through all the rules of using identities, and factoring, and using algebra, and addition, subtraction, all of that stuff, that I can get to where I want to be. So now I rewrite the secants, and that's going to be 1 divided by cosine theta minus cosine theta, all divided by 1 divided by cosine theta plus cosine theta. Here we go again with fractions within fractions. So I need to get common denominators. I need to put these things back together. So in the numerator, I'm going to have 1 over cosine theta minus, I need to introduce a cosine theta in the numerator and a cosine theta in the denominator. That's one option. Okay, and when I get done with this, I'll tell you about another option that would have been possible. All right, so I end up with then, if I introduce, I get cosine squared theta divided by cosine theta, all divided by 1 divided by cosine theta. And then again, I need to introduce what I need to get common denominators. So now I have a cosine squared theta divided by cosine theta. Let's rewrite all of this as one fraction divided by another fraction. So I'm going to get 1 minus cosine squared theta divided by cosine theta, all of which then is 1 plus cosine theta, and that part is divided by cosine theta. Again, I don't have a choice. I don't have enough space. I've got to go through and do this. We also talked about in one of the earlier examples, I don't remember if it was from video 1 or from video 2, but if I have a cosine, for this example, if my denominators of each, the numerator and denominator, are the same, we showed by multiplying by the reciprocal of the denominator that those two things will, simplify out to just being a factor of 1. So I'm going to just skip that part of what we did in the other example and just know that those two denominators will basically disappear. So I'm going to be left with then 1 minus cosine squared theta divided by 1 plus cosine squared theta. So this is kind of nice, right? I now have the denominator that I need, but I need to get this numerator. So somehow sine squared theta has to come into play. Again, I got that magical number 1. So I'm going to take that 1 and I'm going to use the Pythagorean identity to switch this out. So that gives me sine squared theta plus cosine squared theta minus cosine squared theta, all of which is divided by 1 plus cosine squared theta. Well, we see here that the cosine squared theta minus cosine squared theta, they will add out to 0, and I'm then left with exactly what we're looking for, sine squared theta divided by 1 plus cosine squared theta. All right, so we've gotten to where we needed to be. We only manipulated this left-hand side. We kept thinking about where I needed to be and where I had to go. And then look, I just happened to pop that out. That's what we needed for our denominator. So we should only now use the numerator to manipulate and not go any further. All right, so we've gone through a lot of examples on these last 3 videos. So again, I appreciate your time, your effort, and everything that you do to try to learn pre-calculus. If this was helpful at all, please go ahead and subscribe to the Charahoe Pre-Calculus YouTube page. Thank you very much for your time, and hope you enjoy the rest of your day.